Hi, this project was done by Andrew Hatt and Ramit Mahajan from Group 69. In this project, we are trying to build a portable station for testing different encryption algorithms. We'll attack a target microcontroller running an encryption algorithm by tracing the power consumption and electromagnetic waves produced by the board over time and analyze those traces to break the encryption. This is our first setup. Here we'll measure the power consumption of the chip whisperer target board by directly connecting it to the capture board using SMA cable. Here in the next video, you will see the initial condition of the board before testing. Now I will run the AH encryption code inside the target board and trigger the capture board to start measuring the power consumption values and store them. This code is written in Python and is running via Jupyter Notebook, which is an interface using for running codes in Jupyter board. In the next video, you will see that there's a green light that starts blinking on the capture board. This means that the capture board has started capturing the power consumption values and our setup is running fine. Now here in the next video you will see the graph showing the collected power consumption values of the target board over a period of time. Now we will move to a second setup in which we will measure the electromagnetic field produced by the target board while running. It will be measured by using a H field probe which is connected to a low signal amplifier to amplify the signals. You can see the initial condition of the board. Here I will again run the code in Jupyter Notebook in the same way, and if you notice again in the video, the green light start blinking on the capture board, which means the capture board is starting measuring the electromagnetic waves. Here in the graph, we will see that the radiations have been measured over a period of time. Now I'll transfer those traces to my partner and we will try to break the encryption.
Here we have our statistical analysis software. It's a Jupyter notebook with MATLAB kernel. So it helps us determine the secret key as well as the security of encrypted communications. So it starts out with it must be given some electromagnetic power traces. In this script, it's given 10. So let's look at the correlation coefficient graph, which compares the measured and predicted power traces for 10 traces. We would be looking for spikes in this, which would indicate a high correlation for a given set of keys. But there's too much electromagnetic noise. There's no useful information from this graph. So let's try it again with 200 traces. With more information, we should get better results. And sure enough, the correlation coefficient graph has some very noticeable spikes. Using some MATLAB code, we can search through that for the maximum correlation, which is at key value 44 with correlation of 96%. So using differential power analysis, we have determined that the key value for that byte is 44.